Have you ever stopped to think about how your phone can find one single contact name out of thousands in literally the blink of an eye? Well, today we're going to pull back the curtain on the simple yet super powerful secrets behind one of the most basic tasks in all of computing, finding things, and finding them fast. I mean, seriously, think about it. You search for a file on your laptop, a name in your phone, and bam, it's just there, instantly. How in the world does a machine sift through maybe millions of pieces of information to find that one specific thing you're looking for? That's the big puzzle we're going to solve right now. It all boils down to this one simple idea: searching. And in the world of computer science, there are two really foundational ways to do it. We're going to break them both down. One that's super simple and straightforward, and another one that's just ridiculously fast and honestly kind of genius. So let's start with the most obvious method, the one that makes the most intuitive sense. It's called linear search. You can basically think of this as the common sense approach. It's exactly how you or I would probably start looking for something if we didn't have a specific strategy. Yep, it's really that simple. You've got a big list of stuff, and you need to find one thing in it. So what do? You start at the very beginning, and you check every single item one after the other until you finally hit the one you're looking for. The logic behind it is just beautifully simple. You start at position 1, and you ask, is this what I'm looking for? If it is, great, you're done. If not, you just move on to the next one. How about this one? And you just keep doing that, step by step by step, until you either find your match or you run out of things to check. It's a straight line from start to finish. So when would you actually use this? Well, it's perfect for when your list is a complete mess, totally unsorted. It's also totally fine for small lists where you don't really care about lightning speed. Its biggest strength, for sure, is just how simple it is. But, and this is a huge but, what if your friend lives at the very end of a street that has a million houses? You'd have to knock on 999,999 other doors first. You can see how for really big lists of data, this one-by-one method becomes painfully, almost uselessly slow. And that brings us to a much, much smarter way to do things. All right, now for the cool part. Let's talk about binary search. This is the high-performance engine of searching. It's the classic work smarter, not harder approach. It's elegant, it's efficient, and when you see how it works, it's just mind-blowingly fast. Now, the incredible power of binary search comes with one rule. It's a big one. It's non-negotiable. The list you're searching must be sorted. Think numbers from low to high or words in perfect alphabetical order, like a dictionary. This one rule is the key to the whole trick. The magic of binary search is something we call divide and conquer. Instead of starting at the beginning, you jump straight to the middle of the list. You check that one item. Now, if your target is smaller than that middle item, you instantly know it can't be in the entire second half of the list, right? So you just throw that entire half away. If your target is larger, you throw away the first half. With every single guess, you chop your search area in half. It's brilliant. So this method becomes your absolute go-to when you're dealing with huge amounts of data, and speed is everything. We're talking databases, online dictionaries, any massive collection of info. But you gotta remember, it only works if that data is already sorted. Okay, so we've got our two contenders, the simple, steady worker and the lightning-fast, strategic genius. Let's put them side by side and really see how they stack up when we're talking about speed versus simplicity. And whoa, look at this. The difference in performance is staggering. On a list with, say, 1 million items, a linear search could take, in the worst case, 1 million steps. But a binary search, because it's cutting the problem in half every single time, it would take 20 steps, tops. The difference isn't just big, it is absolutely astronomical. So it all comes down to this really important trade-off. Linear search gives you total flexibility. It'll work on any list, no preparation needed. Binary search gives you just unbelievable speed, but it demands that you sort the list first. It's the simple path versus the fast path. This table just lays it all out, plain and simple. Look at the strategy line. Check one by one versus the much cooler divide and conquer. And then look at the performance on a big list. Poor for linear, excellent for binary. It makes the choice crystal clear, depending on what you need. So look, this isn't about one method being better than the other all the time. Not at all. It's about picking the right tool for the right job. Let's make this super clear with a couple of real-world examples. Okay, Picture this. You've got a sign-up sheet for a school club, and the names are just written down in whatever order people signed up. If you need to find Sarah, you have no choice, right? The list is completely random. You have to start at the top and check every name. Linear search is your only option. Now, let's flip that. Imagine a massive university database where thousands of student IDs are all neatly sorted from smallest to largest. If you need to find ID number 120, using linear search would be a crazy waste of time. You'd use binary search to jump right to the middle, narrow it down, and find it in just a handful of steps. And that right there, that is the single biggest takeaway from all of this. It's not just about the search method itself. It's about how that method fits with your data. Is your data all organized and sorted? Go with binary search. Is it a chaotic, jumbled mess? You're stuck with linear search. The structure of your data is everything. So the next time you find a song or a photo on your device in a split second, you'll know. You'll know it's probably some clever divide and conquer trick working its magic behind the scenes. And it kind of makes you wonder, doesn't it? What other beautifully simple but incredibly powerful ideas like this are quietly running our entire digital world?